Hello everyone, welcome back on my YouTube channel. Welcome back on my physics corner. Today I'm going to share you regarding solving question in physics A level. This is about moment of inertia. Yes, I have one question. Yeah, there are some student from Nepal sent me in my Facebook. Yes, they need to solve this question. Okay, let me try to solve this question. Yeah. And don't forget to subscribe my YouTube channel, like, comment, also share with the others. Yeah. Okay, we have one question here like this one. Yeah. Or I just read from my friend on Facebook. So we can say here this equation is this the question is, yeah. Okay, I will read it first. Yeah, for the apparatus shown in the figure, yeah, there is no slipping between the core and the surface of the pulley. The blocks have mass m1, here m1, 4.3 kilogram, and m2 has mass 11.7 kilograms, and the poly has a radius of r equals to 0.302 meter, and mass of cylinder, here cylinder, 14.8 kilograms. Assume that poly has moment of inertia of the uniform cylinder I cylinder. Moment inertia of cylinder equals to a half mass of cylinder r square, or a radius of cylinder. Okay, we have two questions here. Question A is, at the instant the mass m2 has fallen 1.1 meter, yeah, from rest, yeah, find the speed of each block. Then B question, once gravity has done minus 41.5 joule, yes, the work done by m1, what percentage of total kinetic energy of the system is the rational kinetic energy of the poly? Okay, we try to solve this question. Yeah, and if you want to read first, you want to see the question first. Yeah, just see here. Yes, we have this is cylinder. Yeah, and has mass as the 14.8 kilograms. So question one is split each block, yeah, when mass one has height 1.10 meter. Yeah. Okay, actually M2 bigger than of M1. Yeah, we know the direction of this system equal uh, for the M1 is go up, and the for M2 is go down. Yeah. Okay, for the first, we try to solve this question actually about the drawing the force acting on this object. Yeah. So, see on the M1 has weight as the M1 times G, and M1 also have tension rope here. Yeah. And on the cylinder has tension rope also T. Yeah. Let's say this is T1, this is also T1. Yeah. And work at the radius r, yeah, radius r, and also this is radius r also, and work t2, yeah, here, yes, And M2 has also a weight as the M2 times G and have T, yeah, tension group as the T2. Yes, we can separate this system as three system. Yeah, here is system of M1. Here is system of M2, and here is system of cylinder. So we can find the speed of each block when we get the value of acceleration. Yes, this is like the linear motion here. So we have the theoretical of this moment of inertia. That's two conditions. For the first is total force equals to ma, and for the second is total force equals to, so for total torque equal to I alpha. Yes, we will try to solve this question by this equation. Yeah. This is actually for mass 1 and mass 2. This is actually for cylinder. Yeah. Now we try to break down the equation from this formula. Yeah. Let's see on the mass 1. Total force on the mass 1 equals to uh, M1. Yeah, the big one, M1 A. And here we have, if the direction on M1 is go up, yeah, upward, so we can see T1, yeah, minus M1 G equals to M1 A. So, and total force in object 2 as the M2 A. We have on the M2 we have M2G minus T2, yes, equals to M2A. On if we see the separate there on tension group, yeah, T1 equals to M1, yeah, this is A or G plus A, and Ct2 from this equation equals to M2, yes, this is G minus A. So T1 and T2 equals to M1 plus G plus A and M2 G minus A. Okay, now this is about the system on the M1 and M2. So what about the system on the cylinder? Yeah. Okay, on the cylinder, yeah, we have this. Uh, on the cylinder, we have total torque equals to IA. Total torque as the, see on the direction of this rotation, we can say T2 is same direction with the flowing of the M2 and M1. So we can say this is T2 times R minus T1 times R equals to I as the cylinder, I cylinder as the half mass cylinder R square. Okay, we can neglect or we can cancel about the r, yeah, because this is r square, this is r, so we can cancel 1. Yes, finally we get T2 minus T1 as the half of M cylinder times r. Yeah, here T1, here T2, and here the equation relationship between T2 and T1. Okay. Now, what about the others? What about the how to combine this formula? Yes, yeah. Just we go here. Yeah, this is actually m1 g plus a, m2 g minus a equals to a half ma r. Yeah. So if we let me to erase for about this area. So let's say, for example, I want to erase here for the solve here. Sorry, we go here. Yeah, we have here. Yeah, yeah. Let me continue about this one. T2 as the M2G. Yeah, yes. Say M2 has cylinder 11.7. This is 10 plus A. Yes, this is as the T2. Yeah, and minus T1 M1 as the 4.30 times with, yes, G plus A. Oh, sorry, here 10 minus A. Yeah, 10 minus A. This is T2 here, 10 minus A, and here is 10 plus A. Yes, equals to a half of mass of cylinder 14.8. Oh, sorry, and R equals to, yes, 0.342. Yeah. Let's say, sorry, this is a half of mass cylinder is 14.8, and here is 0.302. 302. Yeah, sorry. Yeah. Okay, this is the equation between T2 and T1 and cylinder mass also, and this is T1 and this is 2, and we combine this equation in one equation to find, actually find A, find acceleration first. Yeah, so here is, yeah, let's say this is 11.7 A minus, can actually this is bracket. If we just break it here, yeah, break it here, and we can say here is 43 minus, yeah, oh sorry, this is plus, yeah, minus, yes, minus again 4.30 a m. Yes, we need calculator to find the number of here, yeah, 14.8, 14.8 uh, divided by 2 and times with 0.302. Yes, 2.23. Here is 2.23. Let's say for 8. Yeah. Then finally we get here and here. Yeah. 11.7. Let's say 11 point 7. Yeah. Plus 4.3. Yes. 16. Oh, you can feel it. This is 16A. 16A, yeah, equals to 117 here, yes, minus 43, and minus also 2.2, 2.2348. Yes, we have here is 7.67 here, yeah. Let's say iris again, yeah. Here is 16A equals to 71.76, yeah, equals to 16A. So we have A as the, yes, we divided by 16. Yes, 4.48, yeah. We can say this is the acceleration is 4.48, yeah. meter second minus 2. Okay, I block first about the acceleration here. Uh, yes, and then after that we can find the, yeah, speed h mass. Yeah, speed h mass. Okay, I want to erase first again about this explanation. Finally, we already know about this one. Yeah, we will continue about the further question. Actually, this is still a half of question. Yeah, maybe not a half, a quarter. Okay, now what about this bit of each block when, yeah, when they come from rest, yeah, they come from rest actually initial velocity as the 0 meter second, and they have h as the 1.10 meter, and they have the acceleration is 4.48 meter second minus 2. So how to find speed at the time? Yes, which one we use the equation is? Yes, we use equation of the Vt square equals to Vo square plus 2AH, yeah, because h equals to distance. So we can say Vt square equals to, this is 0 plus 2A as the 4.48 and H as the 1.10. So Vt equals to, after we get this number and then root it here because this is square. So we calculate this number as the 2 times with 4.48 and times again with 1.1. So we get 9.8, yeah, 9.856, and we root it, this question, oh, sorry, 9.8, oh, yes, we root it as become the number of, yes, 3.13 meter second, 3.14, yeah, actually 3.14 meter second. Okay, this is as the speed each block when they go, yeah, after they have the h as the 1.1 meter. Yes, here I block here, yeah. Yes, finally we get one number for this question, and we continue again with other question, yeah. Let me to read again about the question 2 is, but as I mentioned before, please don't forget to subscribe my YouTube channel. Subscribe, like, also comment about this explanation. Is it any wrong? Is it any false on the explanation? Yes, question B is, once gravity has done 4.1 for, yes, I need to erase some here, yeah. Okay, I think, oh, yes. What percentage of total kinetic energy, yeah, yes, what percentage of total kinetic energy of the system is the rotational kinetic energy of Pali? Okay. Uh, we need the total kinetic actually. Erase first this drawing. Yeah, I think enough for explanation about the flowing of force. So we can use this spot to explain my breakdown formula. So kinetic energy, yeah, of mass 1 as the half of 4to, yeah, times with velocity as the 3 point square. Yeah. I will find first what these numbers. Yeah. Yes. Square. Yes. times with 4.3 and divided by 2. Yes, we get 20 as the 21.19 joules. Then kinetic energy 2 as the half of 11.7 kilogram, and velocity is 3.14 square. Yes. Uh, 3.14 square, yes, times with 11.7 and divided by 2, we get number 50. Yes, this is 57.67 joules. Okay, now if this sum, this addition of this number, yeah, so we can say 57.67 plus, yeah, 21.19, so we get 78.8, sorry, 86, yeah, joules. Okay, this is a total kinetic energy when the object is moving, yeah, and if we combine, if we see the percentage when the 41.5, yeah, so percentage of kinetic energy we have here is the 41.5 joule divided by 78.69, yeah, times 100%. So we get, yeah, actually negative is the uh, decreases or the direction of the potential energy is negative. So we can say here is positive. Yeah. Then, yes, we use calculator again for this number 41. Yes, for 41.5 and divided by 7.8. Sorry, 7.6. Yeah. Yes, actually, this is 0.52 times 100%. So we can say the percentage is, we can say 0.52%, or this is 52% of percentage. Okay, I think enough for this session solving this question about the moment inertia. And I hope you understand about this explanation, or if you have any something mistake, or any if you have any something they have to uh, like missing on the explanation, please give me the comment. And also if you have this is necessary for the others to share it, please share it to the others here. Thank you very much. Don't forget to subscribe. Again, don't forget to subscribe, and see you in other video. Thank you very much.